All right, number 8. We have 8 parts. First, we want to graph f of x is equal to x squared plus 4. And we want to do that for x is less than or equal to 0. So you can plot points to graph this. There is a pattern when graphing parabolas that are x squared. You start at 0, 0, and then you're counting basically by odd numbers. You go right 1 and up 1, and then you go right 1 and up 3, 1, 2, 3, and then right 1 and up 5, 1, 2, 3, 4, 5. And so it's pretty much landing on those perfect squares. Like 1 squared is 1, 2 squared is 4, and so when you go up 1 and then you go up 3, you're landing at 4. And then from there you go up 5, you land at 9, which is 3 squared. So this pattern will work when you graph a parabola. What also is going to happen, of course, you're going to get a mirror image. What also you want to be aware of is that we're going to restrict this for x is less than or equal to 0. So we're going to be cutting off this right half, and we're going to be focusing on the left half of this parabola. I want to show this in the calculator as well. I'm going to clear everything I have, and I'm going to go to y equals. So I'm going to show you how to graph this function, and then we're going to do it on the Aleks platform. So I'm going to go to y equal. I'm going to type in the function, but I'm going to do this in parentheses so I can add the restriction. So I'm going to open parentheses and do x squared plus 4, close parentheses. So when I graph this right now, this is what I get. The graph is shifted up 4. If you want to talk about transformations, all you're doing is shifting it up 4 units and then still doing that same pattern. If I want to see the restriction, I'm going to go back to y equal. I'm going to go to the very back, and then I'm going to do divided by. So when you do divided by, this is going to imply the restriction. Open parentheses, we're going to do x, and then we're going to do less than or equal to. To get less than or equal to, we're going to go to test. It's above math in blue. So I have to hit second, and then the math button, and it pulls up the logic or the test symbols. Number 6 is the one I want, and then we're going to do 0. And then when we graph it, okay, you only see the left side of the parabola. All right, so what we're going to do, we're going to plot some points. So this is a parabola centered at 0, 0, but it's got shifted up 4 units. So I'm going to go up 4. So if you were to plug a 0 in, 0 squared is 0 plus 4, so you get the point 0, 4. Then if you go left 1 and up 1, you'll get that point. And then you go left 1 and up 3, 1, 2, 3, you'll get that point, and so forth and so on. All right. So now that I have a few points plotted, I'm going to tell it parabola. You put the vertex down, and then it said curve opens up, so it's opening up because it's positive, and then you just take it through another point, so we get this graph. Let's zoom in. Oh, my bad. We gotta cut the left side off. So I want to only graph the left side, so I need to cut. So what it tells you is that we're going to enter a point where you would like to cut the graph, then click done, and then we're going to use the eraser. All right, so we want to cut it in the center where the vertex was, so that was at 0, 4. The vertex was 0, 4. So it's telling it to cut it. Now I'm going to use the eraser, and you can pick whatever side, and so whatever side you want to cut it, just hit the eraser and click it. All right, so this is the graph that we want. Sorry. All right, so once we have our graph, it says from this graph, is it a one-to-one function? All right, so now that we've cut that right side off, if I do a horizontal line, it only crosses once. If I do a vertical line, it only crosses once. So it is a one-to-one function. All right. The next part says write the domain. So normally the domain is all real. Since we have cut off the right side, this is our domain, x is less than 0. So it's pretty much going from negative infinity, because we go smallest to largest, negative infinity up to 0. So we will include the 0 because it has an equal to sign right here. So we're going to do left side parentheses for the negative infinity up to 0. All right. Part 4, it says what is the range? Okay, so you can kind of see this graph. The range, again, you want to do the smallest to the largest. So we're down at a low of 4, and it's going to go up to positive infinity. So my range is from y equals 4 up to positive infinity. We're going to do a bracket on the lower end this time. 4 is the lower number up to positive infinity. All right. And now we're going to find the inverse. So working the inverse, okay, so here's our function. We're going to switch places with x and y. And then we're going to solve for x. So I would subtract 4. And then we're going to do the square root. So square root, you get plus or minus. Okay, this is going to get rid of the squared, and that's going to leave me with y equals square root of x minus 4. Now, how do I know positive or negative? Because if I do it, if I was to graph this whole thing, it would give me something like this. Okay, and that's not one-to-one. So since we cut off the right side, we're only looking at the negative x values. That tells me that we want the negative square root. So this is going to be our inverse, and then we're going to go back and change this to f inverse of x, which is negative square root of x minus 4. Now, I'm pretty sure we're going to graph this, so let's talk about what this graph looks like. So square root, that minus 4 means it's going to shift right 4. 1, 2, 3, 4. And then we're going to get the negative values. So it's going to curve out like that. This would be the graph that we're going to be looking for. So the function is negative square root of x minus 4. I'm sorry, I got 4 minus 4. I need x minus 4. All right. There's a green check. All right, so now it wants us to graph it. Okay, so we can plot some points. So if you plug in, we want to get numbers so that this works out positive. So I can't use 0. So we flip-flop. So let me make this point clear also. Whenever you interchange x and y, your domain and range are changed. So we're really looking at y values and x values. So like domain is x, range is y. So when you flip-flop your domain and range, your x and y, you also flip-flop your domain and range. So we are going to be plugging in 4 and numbers greater on the x-axis. That's the same thing that we just noticed on our range a while ago. So I can plug in 4. It's going to be my starting point. 4 minus 4 gives me 0. That's the smallest number we can use. So I'm going to plot a point at 4, 0. And then I want a number that's going to give me positive. So if I plug in 5, 5 minus 4 is 1. Square root of 1 is 1, but it's going to be negative. So I'm going to do 5 and negative 1. All right, I'm going to click this, put this point here, and then that'll give me our graph. All right, so we have both graphs. It now wants to know what is the domain. So again, what I was kind of mentioning, when you do the inverse and you interchange x and y, you interchange your domain and range. So you can pretty much just use the domain and range up above. So this was your domain, this is now your range, and then this was your range, it is now your new domain. So we're just going to be inverting those. So my domain, okay, as you can see, is going from +4 to infinity, and that was the range. Okay, so I'm going to put +4 to infinity. And 8 wants to know what is the range. So the range is now my new domain. So you always got to go from the bottom to top, lowest numbers to the largest number. So this is going down to -infinity and then up to 0. So same thing that we have right here, -infinity to 0. That is my new range for my inverse. All right, that's good.